Page 91. Brake system. It stops the car by using a hydraulic system and air pressure to stop the wheels. Brake oil. Brake oil is like blood circulating through the brake system to make parts function correctly. Brake oil is one type of hydraulic oil. It transmits the pressure when we step on the brake pedal. That means we send the pressure through the brake oil to the part at the other side of the pipe in order to stop the car. For primary maintenance, check brake oil level regularly. If brake oil is decreased or contaminated, the efficiency of the brake system will decrease. If the brake oil is below minimum level, that means the brake pads are eroded and they must be replaced. If one has to step on the brake pedal much lower than before, that means the brake oil is below acceptable level, which is a critical situation. In addition, if the brake oil decreases quickly, this indicates a leak in the system. Notice oil drops or stains after parking the car overnight. This identifies the leaking area. If any leakage is found, fix it as soon as possible. Page 92. Another sign that indicates abnormality of brake system is the stretchy feeling when stepping on the brake pedal. This implies that air leaked into the brake oil system, disabling brake oil's iron-like property. The air could enter the brake oil tube system from any openings, for example, crack, leak, loose pipe, or it could enter through the brake oil container. Refilling brake oil. It is recommended to use the same type and brand you are using. Do not mix them up or use discordantly to the manual. When opened, brake oil will be exposed to humidity. The moisture will decrease its effectiveness and will create rust on metal parts in the brake system. Brake oil can contaminate the atmosphere, therefore it must be drained and replaced on the schedule specified in the manual. Usually, it is scheduled for an every year or mileage at 20,000 kilometers. Page 93. Anti-lock braking system, ABS. Every car has a primary brake system. However, a sudden brake on a slippery road might cause locked wheels. Therefore, ABS is added to reduce such risk. All car manufacturers are always improving the efficiency of the primary brake system in order to stop high-performance cars, which has never stopped in the development of perfect horsepower. For example, efficiently cooling disc brakes, fine brake lining, and many other means. Regardless of superior brake system development, another problem that causes risk for an accident is when the wheels are stopped while the car is still moving. For example, in an immediate brake on a slippery road, when the wheels are locked, the steering wheel will not function as usual, and/or the car might spin. Although a skilled driver can correct this by stepping on the brake pedal repeatedly to prevent locked wheels, it is not likely in a real situation because one might not be able to calm down or do it properly. Page 94. What situations require ABS? In the countries where snowfalls on the roads are covered by ice, ABS is used frequently. However, in tropical countries, ABS works occasionally, such as braking on a smooth but wet road, a sandy curve, and braking on a smooth and clean road suddenly. Not many people see the benefits of ABS in braking while each wheel touches the road surface with different slipperiness, such as driving on the edge of the road. This way, the two right wheels are on a rough surface but the other two wheels are on the sandy flanks. When braking suddenly, the car might spin. If you cannot imagine braking when each wheel touches the surface with different slipperiness, there is a good example from a test drive in a foreign country. In the test course, slippery tiles were paved on one side of a concrete track, with normal friction. The track was sprayed with water continuously. The test began by driving a non-ABS car on the track, making two left wheels run on the normal surface and the other two wheels on the wet tiled surface. When hardly stepping on the brake pedal, the car spun suddenly because the two wheels on wet tiled surface stopped instantly. Page 95. When tested by the ABS car, it was able to brake while the car was running on the track. When driving off the roadway, such as on lateritic soil, dust, or sand, ABS functions well when hardly or suddenly braking. Braking hard on a slippery surface without ABS. Braking hard on a slippery surface with ABS. Brake caliper and wheel speed sensor. An ABS system consists of the following components: wheel speed sensors, a hydraulic motor, control processing unit which coordinates the whole process, brake calipers, some pressure release valves. Page 96. Wheel speed sensor, ABS control module, hydraulic motor and pressure release valves, brake pipe leading to the caliper. Adjusting the space of the brake pedal. The space between the master cylinder and track rod is related to the space of the brake pedal. Therefore, the space between the master cylinder and the track rod must be adjusted as specified, generally 0.3 to 0.5 millimeters, and the space of the brake pedal should be approximately 1 to 3 centimeters. One should check the height of the brake pedal from the floor. This adjustment can be made by adjusting the tuner designed for this purpose. Adjusting the brake pedal height should be made after the brake pedal has been adjusted, because the brake disc height might change when adjusting the space between brake lining and brake disc. Page 97. Adjusting hand brake. Generally, we use the mechanical handbrake, the handle pulling the cable, on the rear wheels near the foot brake. Usually, heavy trucks use the handbrake to stop the propeller shaft. This type of brake is near the joint between the gear and the propeller shaft. Adjusting the handbrake can be done as follows. The tuner is normally located beneath the car. Therefore, drive over a car repair pit or jack up the car and insert the stands. Prepare an open-end wrench and necessary tools. Make sure that the handbrake near the driver's seat is released. Go under the car and tighten the tuning nut. Pull handbrake and see the result when pulling to the set space. If you do not know the set space, pull it about 50 to 70% of the total range. If the brake works fully, it is correct. Go under the car again and then tighten the lock nut of the tuner tightly. When such adjustment has been made, try using the handbrake by following these procedures. A. Drive the car at about 10 kilometers per hour, and then pull the handbrake instead of the foot brake. You should have an assistant to observe outside the car. If both of the rear wheels stop at the same time, it means that the handbrake works normally. B. Another method can be done as follows. While parking, apply the handbrake and then drive the car on the highest gear without releasing the handbrake. If the engine stops, it means that the handbrake is set properly. The average speed of the engine while running should be approximately 600 to 700 cycles per minute. The causes of malfunction include a stretched brake cable and rear wheel brake mechanism stuck joints due to rust or bent joints. Check the joints and lubricate. In contrast, if the handbrake is stuck when released, the cause might be that the tuning nut is too tight, or the spring fell or is worn out, or the brake system is stuck due to rust.